Hey guys, welcome back to STR8CHEM. Now we're going to look at some problem solving in Emission Spectra, part 1. We're going to start by talking about problem number 1. So right here, it says that the first line of the boundless series has a wavelength of 656.3 nanometer. Calculates its frequency. So you are given wavelength. Okay, wavelength is given to you, and you need to find frequency. At first glance, I think some of you guys would be able to know which of the formula that you need to be using to solve these problems. So there will be 2 steps for problem number 1. First one you need to do is to find frequency. You have to decide which formula you need to use. And the correct one that we're going to use is this. Okay, so you have, this is the symbol for frequency over speed of light. Frequency equals to speed of light over wavelength. So you have the wavelength over here, and the wavelength is given to you right there. And you only need to look up for the speed of light. And where you're going to get that from? Well, in exams, they will give it to you. So do you remember? I have given this piece of documents in your Google Classroom. So this is going to be the exact document you will be getting in exams. So from this document, list of selected constant values, speed of light in vacuum is given as 3.0 times 10 to the power of 8 meter per second. Okay, so you're just going to plug in all the values inside the frequency formula. It's a very simple one. And when you proceed by doing step 2, the first thing you need to do is always remember to change nanometer in this form into numerical form. If you forget to do this, then you wouldn't be able to get the correct answer. So always remember to do that. When the question gives you in this nanometer unit form, always change nano into times 10 to the power of -9. Okay? So I'm going to highlight that for you to remember. Use blue. So always remember that nano over here is this, times 10 to the power of -9. Nano. Nano sounds like 9. So nano sounds like small. So that's why you have the negative sign in front of the 9. So nanometer times 10 to the power of -9, a very small number. Okay, and then plugging in all the values inside, you should be able to solve the problems very easily. And the frequency is 4.57 times 10 to the power of 14 per second. So the number over here is making sense because frequency refers to the number of waves going to be produced per second. Okay, so when you look at the calculations, when you consider the units for speed of light is meter per second, and for wavelength, okay, you have the word length, so the unit is going to be meter. So when you cancel that out, you get per second, the unit frequency per second, or sometimes they're going to use hertz. Okay, so you need to be prepared for that one. Okay, sometimes you can use like this. So it's the same as per second. Right. So always remember, frequency means how many peaks of the wave going to be formed in 1 second. So in this piece of information, you can see that in 1 second, there are going to be a lot of waves going to be produced, okay? There are going to be a lot of these waves. Sorry, that's a very bad looking waves. So there are going to be a lot of waves going to be produced in 1 second. So it's a very rapid waves formation for this particular line in Balmer series. Right. Therefore, in exams, they're going to give you 1 mark for your final answers. Always remember to put the correct units. It's very important. And you're going to be getting 1 mark for writing the correct formula sometimes. Now, moving on to a slightly more difficult problem. What you need to do in this question is to calculate wavelength, and it specifically requires you to write in nanometer. And why is this important? You will see afterwards. And you need to find the frequency as well. For what? For the 4th line in Lyman series. Okay, 4th line in Lyman series. So the 4th line here refers to the line spectrum. Okay, do remember how does a line spectrum looks like. Okay, you can go back to the Edpuzzle video so that you would be able to imagine what is going on in problem number 2. Okay, now step number 1. What will happen now? You need to use this formula. Okay, you can use this formula if you want to, because the question wants you to find the wavelength. And then in this formula, you have the symbol for wavelength over here. And you need to find frequency. So by using the, this is what you call as the Rydberg equation, you should be able to find out what is the wavelength. So a few considerations that you need to make before you want to use this formula. You need to know that the n final will always going to be smaller than the n initial. So the way you're going to write it is 1 over n final minus 1 over n initial. And the value over here needs to be smaller than the value that you're going to put there. Why? Because if you do the other way around, you're going to get negative wavelength. And wavelength cannot be negative. Length cannot be in negative value. But energy, yes, you can have it in negative. Now, so the RH value that you need to consider, or the Rydberg constant value that you need to consider, is 1.097 times 10 to the power of 7 per meter. Why? Why did you use the top one, not the bottom one? Because you're dealing with wavelength. Okay? So by doing this, you plug in all the values inside, you should be able to know that you need these information. The question gives a 4th line in Lyman series. Okay, so the information for Lyman series, you know that Lyman series, the n final will be 1. Okay, again, I would like to remind you the mnemonic. Okay, so you can always remember L, B, 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 P. So this is 1, 2, 3, 4, 5. So the n final for Lyman will be 1. And you need to do for the 4th line. So if you want to get an initial, you're going to take 1. Okay, you're just going to put plus 4. So this is just some very simple trick that you can try. So n initial will be 5. Okay, because you want to do for the 4th line over here. So in step 3, you're just going to plug in all the values inside. The RH value, the Rydberg constant, you're going to put it in there, the correct one, make sure. Do not get confused with the 2.186 exponent 10 to the power of negative 18 joule. This one is for the other formula. Okay. So you would be able to get the wavelength equals to 9.496 times 10 to the power of negative 8 meter. But do remember, the question wants you to find that in the form of nanometer. Therefore, you cannot leave your final answer like this. You have to change this into negative 9 before you would be able to change this into nanometer. So how do you do that? By moving this dot to that side, and this will be in this form, and you will get times 10 to the power of negative 9. And this thing over here, we talked about this just now. You can change that into nano like this. So this is the final answer that you're looking for. Okay. So step 4, before we're going to go to step 4, one very interesting thing that I need to point out for all of you is wavelength. The symbol is this, yeah? Okay, we all know that this is the symbol for wavelength. Okay, so that is your wavelength. But if you have, use black instead, if you're going to write that in this form, this is something else. And this is what you call as the point over here. This is the wave number. Okay, so if the question is asking you to find out what is the wave number, you're going to leave your answer in this form. Okay, so you have per meter instead. So this is wave number. This is your wavelength. So remember that, guys. Okay, now step 4. You can proceed to step 4 now to find frequency. What you need to do, you're going to use the same formula, and you're just going to put the speed of light, plug in your wavelength inside. So this is the wavelength you're going to use. You can use this one, you can use this one as well. But remember, do not use this number or format into your calculation, because you have n over here that needs to be changed into times 10 to the power of negative 9 first, before you would be able to use that number for the calculation. And the frequency is 3.16 times 10 to the power of 15. So in exams, they're going to give you 1 mark for this. Okay, when you decide what is the end initial, what is the end final, 1 mark for the substitution, 1 mark for the final answers, 1 mark for here substitution, and 1 mark for the final answers. Don't forget your units. Units plays a very important role in this. Okay, problem number 3. Now, this is similar to what we have done in problem number 2. Okay, but instead of working on Lyman series, in problem number 3, you're going to work with Balmer series instead, and you need to find for the 5th line. Still, you're going to use wavelength, and you're still going to find frequency, but this time we're going to try another way of doing this. Maybe some students would prefer to use this over here. Maybe you want to use delta E instead of 1 over lambda, like what we have done in problem number 2. Maybe you would prefer to use this, okay, to find the wavelength and eventually the frequency. You can actually do that. It's the same thing, but this time, you need to make sure that the N initial comes first, then the N final. So that's the difference over here. For 1 over lambda, it's going to be N final, then N initial. But for the delta E formula, it will be N initial first, then N final. So that is the difference right there. Also, what is different is this. The constant. The constant for Rydberg constant will be 2.18 times 10 to the power of negative 18 joule for delta E formula. Okay, remember that. Now, and the same thing, the question gives you the information about boundless series and in the fifth line. So when you go back to the very simple mnemonic, okay, try to remember LBPBP. So this is N final. 1, 2, 3, 4, 5. Okay, you have 2 over here. And then you're going to be working with the fifth line. So fifth looks like 5. So we're going to plus 5. And this is going to be 7. So right here, you're going to put 7 and initial. And then in step 3, you're just going to plug in all the values inside in the delta E. Don't mix up with 1 lambda, okay? So this is, it's similar, but the way you're going to, the type of Rydberg constant you're going to put is going to be different. And the position for end final and initial is different, so don't mix it up. So you have to decide which one you want to use. So you plug in all the values, you're going to have delta E in negative form. That's okay because this one refers to the negative sign over here refers to the release of energy. Okay. So this signifies energy release. Okay. So don't worry about the negative sign. Now, in step 4, what you need to do is you're going to take the value, take the delta E value over here. You're going to plug into this formula, delta E equals to Hc over lambda. And since this time you're going to try to find out for wavelength, you can omit the negative sign. Because the negative sign over here, it's only for the delta E. It wants to tell you that the energy has been released, the negative sign. But if you want to use this piece of information to get the wavelength, you have to ignore the negative sign because wavelength cannot have negative sign. It is a length. Okay? So just by plugging in all the values, you switch over stuff, and eventually you would get the wavelength equals to 3.97 times 10 to the power of negative 7 meter. In step 5, you want to find frequency. Same, you're going to use the frequency equals to c over lambda. This is the speed of light. That is the wavelength of which you have worked out just now right here. And you would be able to get the frequency, the value of frequency. So you'll get 1 mark for this, 1 mark for this. Okay. So those are the marking schemes. For the last problem, we're going to look at this. It looks longer than the other problems is now, but when you read the question carefully, it has enough information for you to use to solve it in 3 steps. Okay, it is not that difficult. So you have to read the question thoroughly. The question says the difference in energy. Okay, so when you read that, difference in energy automatically, you would be directed to delta E. Okay, difference. Look, difference in energy. The symbol delta over here refers to difference. So the difference in energy is given to you, which is 4.09 exponent negative 19. Okay, so that is a difference in energy. Whoops, I need to use a highlighter instead. And you need to do a couple of things. You need to get the wavelength and frequency. Okay, we have done this many times. So how do you do that? You have the difference in energy given to you. So that is a difference in energy. And you can use that to find wavelength. How? You can use this formula, delta E equals to hc over lambda, to find the wavelength. So in step 2, just gonna substitute all the values inside. Okay, so this 4.09 times 10 to the power of negative 19 is given to you in the question. That is the Planck's constant h. Okay, that is the value for h. And this is the speed of light. Maybe I can write that down for you. That is the h. That is the speed of light. Again, from where do you get those values from? From this table over here that will be given to you in exams. So the Planck's constant is 6.6256 times 10 to the power of negative 34 joule per second. So that is the only number that you're going to be using for Planck's constant. So I don't think it's going to be that difficult to be remembered. And simple mathematics is going to move this side to the other sides and this number to over this side for you to get 4.86 times 10 to the power of negative 7 meter. But remember, even though the question doesn't say that, you need to leave in nanometer. Get used to switching that to nanometer for convenience. But if the question doesn't say it, you can leave your answer like this. That is absolutely fine. However, if you have a question like problem number 3, it asks specifically in nanometer. Same goes to problem number 2, specifically in nanometer. Then you need to try your best to change that into nanometer. Otherwise, you're going to lose your 1 mark. Now in step 3, we're going to find frequency. You found wavelength, and now you want to find frequency. That's easy. We have looked at the equation, the formula. What you need to do, you just need to take the wavelength value, you plug it into here, and this is the speed of light. You just put it in there, and you're going to get your frequency. Therefore, in exams, this one will be 1 mark. 1 mark. And this whole thing, perhaps they're going to give you 1 mark. Okay, so sometimes they're going to give you 1 mark for the substitution and 1 mark for the final answer, but sometimes it will be in package. So you have to be prepared for both situations.